All right, welcome everybody to Unit 8.7. We are finally at the end of the road for our work with quadratics. So today we're going to be looking at vertex form, which is an additional way that we can write quadratic equations that's different from ax squared plus bx plus c that we've been looking at all along. Okay, so vertex form can be written as y equals a times x minus h squared plus k. So we see that the only things that are the same between ax squared plus bx plus c and vertex form, the only variables that appear the same are the a, and of course the x and the y. But now we're introduced to two different variables, h and k, and they're each going to serve a specific purpose in vertex form. Okay, so again, that's our equation for vertex form. Okay. The vertex of the equation, rather than us having to solve for the opposite of b over 2 times a to get the axis of symmetry and then the vertex, it's listed right there in the equation. We take the value for h and the value for k, but you'll notice in the equation it says x minus h, okay, and whenever we see the minus, okay, a lot with quadratics, this is the opposite. Okay, remember, opposite of b over 2a, opposite of b plus or minus the square root of b squared minus 4ac. Anytime there's a minus with quadratics in the formula, we read it as the opposite. So when we take the vertex of an equation out of vertex form, we take the opposite of that number in the parentheses. So we look at this example on the bottom. It says x minus 7 squared minus 8. The vertex there is really a positive 7 comma negative 8. Okay, because we take the opposite of that inside value. And then you see that the x value in the vertex matches the x value of our axis of symmetry, and we've known that for a while now, way back to 8.1 when we first learned how to graph quadratics. All right, so we're going to do a couple different things here with vertex form. Okay, the first thing we want to do is just identify the axis of symmetry and the vertex. Okay, so remember, axis of symmetry is x equals, and the vertex is an ordered pair. So our first example, okay, my axis of symmetry is coming from that h value, and we take the opposite. Okay, so then my vertex is 5, 6. Notice that we don't use the a value in the front of the equation right now for the vertex or the axis of symmetry. Okay. Example 2, my axis of symmetry is the opposite of h. X equals h. That's the equation here for axis of symmetry. So x equals negative 8. And then my vertex, negative 8 comma negative 10. So remember, those two x values should match. Okay, my third example, you'll notice that plus 6 minus 10, there's nothing on the outside of this equation here. So I'm going to write in a plus 0. Okay, my axis of symmetry, x equals 3, and then my vertex, I need that placeholder of 0. I need a k value on the end. All right, why don't you try and tackle this last one? So pause your video real quick for 30 seconds. Okay, come back and check your answer. Axis of symmetry is x equals 3, and my vertex is negative 3 comma 1. Okay, this question that's hidden here on the bottom, it says, can we determine the direction that each parabola will open? Okay, meaning, does it open up or down? So how can we determine that from vertex form? Okay, we can actually look at the A value in each. Okay, the A value is in front of the parenthesis. Okay, a positive A value opens up and a negative A value opens down. Okay, so that first parabola, A equals -2. So this one is going to open down. Okay, example 2 and example 3, A equals a +1. Okay, because there is not actually a coefficient written, which is implied that it's 1. So both of these, the parabola opens up because they are a +1. Okay, and then the last example, A equals 4. This also opens up. It is a positive number. Okay, so without even having to make a graph, we can determine the way that it opens, and then we know if this opens down, oh, well, there's going to be a maximum. And if these three open up, there's going to be a minimum value. All right, so the next thing we want to do is convert from standard form, and standard is that ax squared plus bx plus c, and we want to turn it into vertex form. Okay, so remember vertex form, x minus h squared plus k. So we need the vertex. We need the h and the k value. The a is going to be the same as what's in the equation. Okay, so right now in that equation, the a value is 1. So what I'm going to do is solve for my vertex using opposite of b over 2a, and then I'm just going to plug that value along with a equals 1 into the equation, the formula for vertex form. Okay, so my axis of symmetry here is going to be -6 over 2 times 1, which gets me a -3. So I'm then going to plug that back into the parabola. Okay, oh dear. Just like we did, okay, back in 8.1. So we're going to get -2, so that means my vertex is -3, -2. All right, so plugging all of these values in, x plus 3, because remember it's the opposite, -2. Okay, and this is now my vertex form. Okay, we'll try this again. So first thing we want to figure out is the a value. So in this case, doesn't like me again today. All right, my a value is 4. And then we're going to find our axis of symmetry and our vertex to plug in. Okay, we get -16 over 8, which is -2 for my axis of symmetry. And then we'll plug that in. Okay, make sure that you're doing order of operations when you evaluate this. Okay, so our vertex is -2, -19. Alright, so we're just going to plug those values. They disappeared on me. Alright, but we're going to plug them in to our vertex form. So remember, it's the opposite from that vertex, so it becomes a plus 2 inside, okay, and then minus 19. All right, so we have one more type of problem we want to look at. We want to go from vertex form into standard form. So we want to turn this into ax squared plus bx plus c. Okay, so the first thing that we're going to do is FOIL. So we're going to take x plus 2 squared, and we're going to FOIL that out. Okay, so if you need those arrows from FOIL, okay, combine like terms on that. So we're going to take that value and insert it back into the parentheses. Okay, and now we're going to distribute the a value. And then combine like terms. Okay, and there we have standard form, ax squared plus bx plus c of that equation. All right, so that's everything here for vertex form, guys. It's really just applying things that we already know into this new equation. All right, so just make sure that you have your notes complete. Write down any questions that you have. All right, thank you so much for watching. I will see you next class.